Hey everyone, I'm Felix and I'll be going over problem number 4 on this week's CSM worksheet. So this problem is a bit on the harder side and therefore I won't be going into every single little detail. But hopefully through this walkthrough it'll give you an idea of how to approach these kind of problems on exams. So in this problem we have been hired by Alan to design some sort of priority queue implementation for Kelp, the new seafood review startup. So this priority queue implementation needs to be ordered on the timestamp of each review. So just so that we have some sort of defined convention, the more recent a review is in time, the higher its timestamp value will be. Sort of like Unix time, if you're familiar with that. This is going to be important later on when we use it for some sort of comparison, but we'll get to that in the future. So just keep this in mind. So we have a couple of constraints we need to meet, which is that we need to be able to insert a review in logarithmic time, edit a review in constant time, return the 61st latest review in constant time as well. So by 61st latest, it means that, for example, if we have all the reviews in just like one big line right here, ordered by their timestamp, we want the 61st latest review. So there's going to be 60 reviews before it, ordered by their time. We want to return this. Not remove it, but just to look at it. And this needs to be done in constant time. Now the final thing is we have to be able to remove and return this 61st latest review in the logarithmic time. So this problem is a little complicated, but let's break it down into chunks that we can more easily reason about. So the first thing to notice is that we always want the 61st latest review no matter what. Now this kind of implies that maybe we want to divide all of our time steps into two sections, like the top and the bottom, where the top has the 61 most recent reviews and the bottom has everything else. A trick that we can do is to make the top a min heap, which means that the oldest review is going to be the top of the heap based on this convention right here. Now we need to make sure an invariant holds. And that invariant is that the top section needs to always contain the 61 most recent reviews. Now there are two methods that interact with this top half. Namely, there's poll 61, which removes the 61st latest, and insert, which might insert into either the top or the bottom section, depending on the review's timestamp. Now, as long as we ensure that this invariant holds through our implementation, then this means that if we look at the top element, it will be the 61 latest review. Because that's just how, if the invariant holds, this must be true. So this will satisfy this right here, where 61, where we want to return the 61st latest review in constant time. We can just peek at the top of this min heap right here, and we'll get the 61st latest review. Now, as for the bottom half, we'll maintain a max heap. And the invariant of this is it must contain all of the reviews that are older than the top 61 reviews, based on their timestamps. Now, if this is true, then that means the top element is going to be the 62nd latest review, because if this is a max heap, the youngest of everything older than 61 is 62. So if we keep this invariant, this will be true. Now this is important as we implement these methods on the right of how we insert into this review structure and remove the 61st latest. So I'll go in this order, which makes more intuitive sense to me. You can implement this in any order, but I just find this the easiest to understand. So the first method is going to be 61, which is we're going to return the 61st latest review in constant time. Now, like I've said, this top heap already has this property that the top element is going to be the 61st latest review. So it's as simple as just returning whatever the top element on the heap is. So we'll just peek and then just return that. Now the next step is a little bit tricky, which is we need to remove and return this review. Now one thing you should notice is that if we remove the top element in this top heap will now have 60 elements. But we want to enforce this invariant that it contains 61 of the most recent reviews. So what we can do is we can use the first element of the bottom heap and put it into the top heap whenever we remove this top element in this top heap. So essentially what that looked like in code is that first we'll get the result by removing it from the top heap. That's what poll does. And then we're going to pull the bottom in order to get the most recent of the 62nd latest review and add it to the top. Now this ensures that both of these invariants are going to be held. This top heap will now have the 61 most recent reviews, and the bottom heap will also have all the reviews that are older than the 61st latest. Now insert's a little bit tricky because there are two cases that might happen. The review we want to insert might be younger than the 61st latest, or it might be older. So we need to do some sort of comparison between the 61st latest review right here and the review that we're trying to insert in. So if we do some comparison here and we find that the review we want to insert, the timestamps larger, this implies that the review is younger and it needs to go into this top heap. Well, if we insert it to the top heap, we're going to have 62 elements, which is violating our invariant. So what we'll do is we'll remove the 61st latest element right here and put it into the bottom heap, and then insert our new review here. Now the heap resorts itself, so this invariant will still hold. Finally, the next step will be what I just said, is to add the review into the top half. Now, the other cases where the review we want to insert is younger than the 61st latest, and that all we need to do is just put it into this bottom half right here. So we'll just simply add it into the bottom heap. Now, there's another constraint or requirement that we need to fulfill, and it's edit. Now, if we scroll up here, we'll see that we need to basically edit a review in constant time. Now, this is pretty simple because all we need to do is essentially slap on a hash map. So if we have a map of all reviews by their IDs, we can just get them from the map by their ID, and then change their body to whatever this method wants. Now, the one thing is that we need to basically tack on these two methods somehow down here. We need to find the location where we put the review into the map and the location that we remove. Well, I think it's pretty intuitive that the place that we need to put it into the map is whenever we insert into the heap. So I think a good place would be right here. Let's move this. Oh, I can't move it. This is pre-drawn. But we would basically add this line right here. After we insert, we just simply put it into the map, and then we'll have it for access for edit. And then the other step is we have to remove it whenever we remove or pop the 61st latest, because as we've designed it, the only way we can remove something from these two heaps is by removing the 61st latest. So you can just add that right here. Alright, so that's the problem. Hopefully that gives you more intuition on how you would approach these kind of problems, maybe just how you reason about them, dividing it into smaller pieces. I will mention that, again, this isn't a very rigorous or complete implementation because there are some details that I haven't included. Namely, the first thing is that you have to populate these two heaps. Like, imagine these two start out empty. We have to basically populate them properly. So you'd probably keep track of the counts in the top heap, and maybe like you have to account for some cases of putting it to the top and the bottom. I didn't include that. There's also the fact that some of these methods right here won't work properly if there are less than 62 elements in total, because basically you'll have 61, like less than 61 elements in the top, and then this bottom will be empty, and there'll probably be some edge cases that aren't accounted for. Either way, that's mainly just an exercise at that point. The main idea I want you to take away from this is just how to kind of approach these kind of problems. So yeah, hopefully this was helpful to you. Good luck on your midterm this week. See you later.